Hi everyone, welcome to our channel Tech Binary Sphere. As always, we are having projects that pick some new and some different. Let's start. In this project, by using some software and a sensor, we are creating an 3D image or say 3D visualization by rotating the sensor in front of the camera of a system. Whenever we rotate or move the sensor, it will be visible on the screen how the movement and the rotation of an object is occurring. So to make this possible, we have used Arduino IDE and a Python with some libraries and a sensor that is called MPU6050. This is our screenshot of how our output looks like, having Arduino IDE's image, Python, and this black box image is our output, a 3D visualization. It is just a screenshot at present now. On later on, we will have a rotation of this a real-time image or real-time motion. And in this video, I am going to explain you everything about the code, how the code works in both the softwares, Python and Arduino, the connection and more. This is the connection between Arduino hardware and a sensor. VCC we have connected with 5 volt ground to ground and SDA that is data pin to A4 of the Arduino and SCL that is clock pin to the A5 of the Arduino. For software we will use Arduino and Python and also some libraries. For hardwares we will use Arduino hardware and MPU6050 sensor and some connecting wires. This is the sensor, a small tiny board. On this tiny board, a small square box that is visible on the screen. This is the main sensor. So in this PCB board, we are having around 8 pins and each pins have different function. First pin is our power pin, 3.3 or 5 volt, and second pin as ground pin. Third and fourth pin is our I2C pin, I2C protocol communication pin, that is SDA and SCL. And the next pin is XDA, that is auxiliary data pin, and next pin is XCL, that is auxiliary clock pin, which will be used for the other sensor if you want to connect with them for other purposes. The next pin is our AD0, that is for I2C slave address. So this pin is used to set the I2C address of the devices. This sensor can communicate over the I2C bus if we are using one or two possible addresses, which allows us to connect two MPU6050 sensor to the same I2C bus without address conflicts. So you can do using some register values. If you connect AD0 to the low pin, if you connect AD0 to the low, that is ground pin, your address will be 0x68, and if you connect AD0 to high, that is for VCC pin, then your address will be 0x69. So this 24 pin chip have some functions. It is a 6-axis motion tracking device. 6-axis means a combination of 3 axis of gyroscope and 3 axis of accelerometer. When I'm talking about 3 axis, these are X, Y and Z, and a digital motion processor, and it is a I2C protocol, and there is a some values, that is 250, 500, 1000 and 2000 degree, and some accelerometer value 2G, 4G, 8G and 16G, which makes it some saturation to detect some small and precise movement. This flexibility makes ensuring motion tracking under various conditions. This is the pin description of our 24 pin chip. This one is MPU6050 sensor, and this is the pin name, and it is the pin description of each pin. So let's what is gyroscope? A gyroscope is a device that measures and maintains orientation and angular velocity. It works based on the principle of angular momentum. And some examples are smartphones, drones, navigation system, and maybe more. Now, next one is our accelerometer. An accelerometer is a device that measures acceleration, which is the rate of change of velocity of an object. For example, wearable fitness devices, gaming controllers, etc. Some precise value which are different for gyroscope and different for accelerometer. You have to take some values. If you take plus minus 250-degree minimum value or minimum value of accelerometer 2G, then it will be for suitable for detecting slow rotations and providing high sensitivity and precision. So it is a different values which have different functions that depend on us or whatever is your work, whatever is your need. It is an internal digital motion processing, sometimes called DMP. Engine supports 3D motion processing and gesture recognition algorithm. This this sensor MPU6050 collects gyroscope and accelerometer data while synchronizing data sampling at a user-defined rate. The total data set obtained by the sensor includes 3-axis gyroscope and 3-axis of accelerometer data, and we can also calculate the values of temperature. We have some applications also. By using the sensor, we can do video and still image stabilization, motion enabled game and application framework, and motion based game controllers. We can also have wearable sensors for health, fitness and sports activities, and also we can use in toys. To download this whole folder, I will give the link of my page in the description. Open that link and follow the instruction as I am explaining here. After opening the link, you will have this page. On the right side, you will have a code option. Click on it and the list will appear. Then click on the zip file. The file will download. After downloading the file, just extract that file. And in that folder, you will have 4 files. First one is MPU6050, that is a library. So once you extract the file, then copy this MPU6050 folder and follow the path. The path is you have to paste that MPU6050 folder in the Arduino library. You have to go to PC, then C, then user, then Dell or your system, whatever, HP, Mac, whatever, then document, then Arduino, and then library folder, paste this folder. After saving the file for the Arduino library, now you have to install the library for the Python. I have added the screenshot. You need to open the command prompt and then you have to type pip install pygame pyserial numpy. This will also I will add in the description of the channel. Then press enter. It will take few minutes. So after pasting the folder MPU6050 library in the Arduino's library, now open the Arduino IDE file that is in the folder that you have extracted. Now after opening the Arduino IDE, this will be look like this. So follow these instructions. It will make you some help to understand all those things. Now check here, click on here. Now select your Arduino UNO and mine COM is 5, your may be different. And remember what is your COM port value, your may be 3 or 5, mine is 5. And follow these instructions. And here is the code. I am going to explain few lines of these codes. So here the 2 lines are hash include wire.h and hash include MPU6050. As we all know, MPU6050 is the sensors library that we have already done this part. So let's talk about the wire.h. So this wire.h is for the I2C protocol. You have to install this library. So here wire.h is used for the I2C protocol. It is the library for this. So after this line MPU6050 MPU, it is for the declaration. This part is for the class declaration and this part is our object declaration. So For class declaration, this class provides function and method to interact with MPU6050 sensor, such as initializing the sensor, reading data from it. And for the object declaration, this object allows you to access the function and method defined in MPU6050 class to interact with the sensor. So here we have used the variable to store accelerometer and gyroscope data. The next line is our void setup function. The setup function runs once the Arduino start. It is used to initialize the setting. The next line is our serial.begin 9600. This serial.begin what does initializes serial communication at a baud rate of 9600. The next line is wire.begin function. This initializes the wire library for I2C communication. The next line is serial.print initializing I2C device. It is printing a message to the serial monitor. Then our next line is MPU initialize function. It is initializing the MPU6050 sensor. Then our next line is serial.print ln. So in this line, what is happening? It is testing the connection to the MPU6050 sensor and prints whether the connection was successful or failed. If it is successful, then it will show connected or not. Now this is the void loop function. What does it do? The loop functions run continuously after the setup function. It is used to repeatedly execute code. Now the next line is MPU.get mention. It is mentioning our all access accelerometers X, AY, AZ and GX, GY, GZ is for gyroscope. So after reading the values from the sensor and storing all the values in the variables, these values are printed in the serial monitor. And we are also having a delay of 100 milliseconds. So after running and compiling the code, this output will be like this. It is showing all the values here. Arduino part is complete. Now we will start for the Python. After everything done in the Arduino IDE, don't forget to close this serial monitor, because if it is open here and if you run the code in the Python, then it will create a problem. It will not show any output. So don't forget to close the serial monitor in the Arduino IDE. So now open the Python IDE. My path is different for the code I have saved where. So this is the Python code here. It is just a very simple code. So these are the import part. This is the initialization part, some display part, and airplane image and its size part. It is the color for the output part, some functions. This is the loop part, and we have now closed the part. So here we have used import serial part. This is used to handle serial communication with the Arduino. And here we have used import Pygame. This is to create the visualization window and handle the graphic. And the import time next line is to introduce the delay. And the next line is our import math. This is used to perform the mathematical operation, especially for calculating our rotational angles. This one is our to initialize Pygame. And then this one is used to set the display size, width and height. So in the code we have used width height. So this is the width and height of the size 600 into 600, and the window is our pygame.display.set mode. And also we have used MPU6050 data visualization to set the caption. Here it is captioned here. So in this line, window equals to pygame dot display dot set underscore mode in the bracket width and height. This is used to create the display window with the specified size. And in the next line, pygame dot display dot set underscore caption. This one is used to set the window's title. As you can see, the title of this window is visible here. And one more thing, to create this image, as if you need aeroplane or something else, you need to download the file and name the file of this like this, airplane.png, and the size will be like this, 500 and 400. The size of this image is 500 into 400. So here what is happening, here it defines a function to initialize the serial connection. Here we have used port, as we remember in Arduino we have used COM5 as our COM port, and the baud rate is communication speed, that is 9600 baud rate. Here it is trying to create a serial connection. If it doesn't work, then it will produce an error. So in this, as I have said, this code is asking for to produce the COM port. Let me show you. Now it is asking what is your COM port. I have shown here example COM5. If I say COM3, COM4, it will show an error. Now I am giving the COM5. Now after pressing the enter, now it is working. This is the 3D visualization which will look like this. Let me explain more about the code. Then you will see this 3D visualization. Now this is the main loop. So in this main loop, what is happening? Running equals to true. A flag to keep the loop running. So that's why we have written here running equals to 2. The next line is our while running. This loop will continue until running is set to be false. And in the next line, for event in pygame.event.get function, what is happening here? Processes pygame event. Example, window is closed or something else. And in the next line, it is checking the user. So in the next line, if event type equals to pygame.quit, checks if the user closed the window or not. And in the next line, running equals to false, it means stop the loop if the window is closed. So in this part of code, what is happening here? In this line, it is checking if there is data waiting in the serial buffer or not. Then in this line, and in this line, what is happening? It is reading a line of data and decodes it from bytes to a string and removes any trailing white spaces. And in the next line, what is happening? It prints the raw data for the debugging part. In this line, what is happening? It checks if the line starts with a/g, and then in this line, what is happening? It splits the line into parts, removing this ag part. And in this line, it is converting the parts to floats and ignoring any empty values. But there are exactly 6 values, 3 for the accelerometer and 3 for the gyroscope. And in the next line, this one, it assigns the values to corresponding variables. And after this, it prints the passed value for the debugging. Now, in this part of the code, what is happening? It fills the window with the black color, and here it calculates the rotational angle based on the gyroscope data, that is AY, AZ, and here is the formula, rotation of the airplane image. So in this part, what is happening? It is creating image in the center of the box. So that's why we have used this formula. Get airplane image, and here it is a blit. What is blit? This method is used to draw one image onto another. And in this pygame.display.flip function, what is happening? It updates the entire display surface to the screen. And in this part of the code, what is happening? It prints an error if the data format is incorrect. And in this line, what is happening? It prints an error message if there is an exception while reading or processing the data. There is some errors or something else. So it gives the error for the data. So in this second last line, serial.close, it closes the serial connection. Last line, pygame.quit, it quits pygame and clean up the resources. So this is the part of our programming. Let's do our 3D visualization part. I will show you how it is running.